How do we find the center of mass of the thin plate of constant density in the shape of the region shown in the diagram? It's bounded on the left by the parabola x equals y squared minus 3, and on the right by x equals negative 2y squared. Well, first of all, I want you to notice that the region is symmetric with respect to the x-axis. That, coupled with the fact that the density is constant, means that the center of mass lies somewhere on the x-axis, which means somewhere in here, which means that the y-coordinate of the center of mass must be 0. Now, if the density weren't constant, then I wouldn't necessarily be able to draw that conclusion. The x-coordinate, well, that's going to be a little bit more difficult. Symmetry isn't going to help me here. So I use the fact that the x-coordinate of the center of mass is the moment about the y-axis divided by the mass of the region. And next thing I need to do is partition the region either into horizontal rectangular strips or vertical rectangular strips. It's best to use horizontal strips. If I use vertical strips, I'm going to have to divide the region into two parts, and each integral will end up being the sum of two integrals, and I'd prefer not to do that. So here's a typical horizontal strip. Here's its center of mass. It's right in the middle. Middle between, when I say it's right in the middle, the x-coordinate is halfway between here and here, and the y-coordinate is halfway between the bottom edge and the top edge. Anyways, let's call this x tilde y tilde. And remember that m sub y is the integral of x tilde times dm, and the mass m is the integral of dm, where dm is the differential of mass. Let's calculate that. The differential of mass is the mass of this rectangular strip. To get the mass, we multiply the density, which we've been calling delta, so we'll continue to do so, times the area of the region. The area of a rectangle is length times width. The width is dy. What's the length? Well, it's this number minus this number. What's this number? Well, it's negative 2y squared minus this number here. Simplify, we get negative 3y squared plus 3. What about x tilde? Well, like I said, x tilde is halfway between here and here. In other words, it's the average of these two numbers. How do you average two numbers? Well, you add them together, divide by 2. So add this to this. Divide by 2. Simplify, you get 1/2 negative y squared minus 3. So here we go. M sub y is the integral from negative 1 to 1 of x tilde, which is this. Pull the 1/2 out. Times dm, which is, well, let's pull the delta out. It's constant. Negative 3y squared plus 3. Multiply 3y to the 4th plus 9y squared minus 3y squared is plus 6y squared minus 9. Anti-differentiate 3/5 y to the 5 plus 6 thirds, which is 2, y cubed minus 9y. It's running from -1 to 1. So that's delta halves. Evaluate the antiderivative at 1. 3/5 plus 2 minus 9. Well, 2 minus 9 is -7, so 3/5 minus 7. And then evaluate what you get when you plug in -1. That's -3/5. And it looks like that's going to be plus 7. So we have 3/5 plus 3/5, which is 6/5. And then I have 7 minus 7, which is minus 14. And that gives me -64. Well, what's in brackets is -64/5. Oops, let's be consistent there. So that's what, -32 delta over 5. That's m sub y. Now, what about m? Well, let's do that. M is the integral from -1 to 1 of dm being delta, which is a constant, times -3y squared plus 3 dy. Anti-differentiate, you get minus y cubed plus 3y running from -1 to 1. Plug in 1, you get 2. Subtract what you get when you plug in -1, which is -2. That's what, 4 delta. So x bar, which is the x-coordinate of the center of mass, is, again, m sub y over m, which is -32 delta over 5. Dividing by m is the same thing as multiplying by 1 over m. 32 divided by 4 is 8, so that's -8/5. So the center of mass is -8/5, 0. Ta-da!